Okay, let's have a look at some of these integration questions then. Starting off with a very basic integration method, which is if something is in this form, we have a number, an x, and then a power, you increase the power by 1, so that would become x to the power of 5, and then divide by the new power. So 10 divided by 5 is 2. If you've got fractions, it doesn't make any difference. If you've got negatives, it doesn't make any difference. Okay, you still just increase the power by 1. So this is negative 0.4, so that becomes positive 0.6. And then you do 2 divided by that power. So 10 over 3. I like to keep things as fractions at the front and improper fractions, and then x, and then I would probably normally write this as an improper fraction as well. Sorry, that's just a normal fraction, but I would write my powers as fractions and these as fractions. That's just my preference though. It doesn't make any difference if it is more than one term. You just do one term at a time. So for this one, x to the cubed would be increase the power by 1 and then divide by the new power. So I would write a quarter x to the 4 because then it's still in that form of number, variable, power. Here, 3 over 2, we're going to do, it's going to be x to the power of increase the power by 1, so negative a half plus 1 is a half. Then you're going to do negative 3 over 2 divided by a half, which is negative 3. You can always do these things on a calculator as well. So that would be just negative 3 over 2 divided by a half. So if you're going to make if like you find yourself making mistakes with bits like that, just do them on your calculator instead. Here it's going to be plus x to the power of minus 1 because I've increased the power by 1, and then divide by the new power. That's how I know it's plus, because I'm going to do minus 6 divided by minus 1. If you want to now rearrange that, you can. It says here to simplify your answer. These are pretty simplified already. If you'd rather have it written as, say, x to the 4 over 4 minus 3 root x plus 6 over x, you can. But I would say this is absolutely fine, and that's how I would leave it until I needed to do something with it. By simplify, it means here where I did, for example, minus 6 divided by minus 1, you can't just leave it as minus 6 over minus 1, you've got to do that division. Or negative 3 over 2 divided by a half, you can't just leave it like that, you've got to do the division. Yeah, let's move on. Oh, wait a second, we didn't write plus c on any of those. All of these should have a plus c on them because they're all indefinite integration. These ones slightly more complicated because the first thing you've got to do is write them in index form. So before you do any integration, so notice that my integral sign is still here. I'm going to do 2x cubed divided by x squared, which is 2x. And then 3 divided by x squared, which is 3x to the minus 2. And I would write it in that form. Because you can't do the integration like this with something on the top of the fraction and something on the bottom. I mean, you probably can, but in year 12 what we do is we just simplify this so that it's in the index form. So it goes number, then variable, then power. So the power here is 1, put that in if you want. Increase the power by 1 to 2, and then divide by the new power. And then here, increase the power by 1 to minus 1 and divide by the new power. And then don't forget the plus c. With brackets like this, where it's squared, expand them first and then do your integration. again, multiply everything by root x before you do your integration. Okay, root x is x to the power of a half, so 2x times x to the power of a half is going to be 2x to the power of 3 over 2 plus 3x to the power of a half, and then do your integration. These ones, nothing really is different, except they've got some random letters instead of numbers. Now, you don't do anything different with those as you would a normal number. So, for example, a, first thing you want to do, write it in index form. So ax to the minus 2 minus 3. Then do your integration. So increase the power by 1 to the minus 1, divide by that. But you notice I'm not doing anything with the letter. I'm treating it exactly like a number because it's just a constant. Right? If you ever got a constant like this, P, Q, R, the A over here, nothing different to if it was a number. Also, if it says pi, no different. Okay, so just this one, you'd write it as root P x to the power of a half, and then don't do anything with this root. Okay, it's just a number. The variable here, the one that you're integrating with respect to, is the only thing that has to increase the power and divide by. Okay, if there's something which is just a number, like p is a constant, so the square root of p is also just a constant, you don't need to do anything different with that than you would a normal number. Moving on, other things that you could need to do is go back from a gradient function, integrating it to get the original function. When you do that, they will always give you a point. That is because you need to find out what c is. C, the integral the constant of integration. But what we're going to do, if we've got the derivative already, I'm just going to integrate it. So y equals, increase the power by 1, divide by the new power, plus c. And then once you've got that with a plus c, you put in your values of x and y. So 10 equals 2 cubed plus 2 squared plus c, which means that c is minus 2. Okay, so you can rewrite that y equals x cubed plus x squared minus 2. And that's the same with all of them. Just remember, if it's like this, to write it into index form first. So let me do f. Before you do any kind of integration, do this division. That's x to the power of a half. So 2 minus a half is 3 over 2. And then plus 3x to the minus a half. This, going from here to here, is chapter 1. Okay, so we haven't actually done any integration yet. Once you've got it in index form, then you can do your integration. So increase the power by 1 to 5 over 2, divide by that, and then that increases to 1 over 2, divide by that, plus c. Then put in your point, so y equals mx, not mx, I don't know why. Just substitute in 0 here, they both become 0, plus c, so c is 1, and your equation is y equals 2/5 x to the 5 over 2 plus 6 x to the half plus 1. Okay, they're all very similar. This one, so first thing you should notice is that it's not in index form, so write it in index form is actually the first question. So 6x to the half plus 5x. So p is a half, q is 1. Here's just 3 over 2, subtract 1 over 2, which is 1. And then the second bit, given that the dy by dx is this, and that y is 100 when x is 9, find y in terms of x, simplifying each coefficient. So it's just another coordinate. I'm not going to bother doing it. It would just be integrating and then substitute y and x in to find c. Moving on to the intermediate type questions, we get to definite integration. I've put it in intermediate because the first thing you've got to do is integrate, and then the second thing is substitute in the values and subtract. So there's just more stages. I wouldn't say any of the individual stages are that difficult. If you can integrate, like if you can do indefinite integration, you can do definite integration, the first step at least. And if you can, substitute you'll find it easier to. So I'm going to write it in properly, and then take away when it's definite integration. See if I integration, you can put it in to the power of -2, and then you want 1 and 3, and then if you've got it right, you can just be happy that you've got it right, and move on with the question. So the 2 there means that I've done that correctly. Most of the time with these questions, there's either a letter in here, which means you can't put it into the calculator because you can't put, when I say a letter, I mean a constant that you don't know rather than the x. Or it will say something about you not being able to rely on calculator technology. So you do need to show your working, but you can then check your answer with a calculator. These ones will be the same, it's just a little bit more tricky because you have to simplify them into index form first. The next bit is areas under graphs, so that bit there is supposed to be the bit that's shaded. Find the area of the shaded region. It's already done a lot of it for you, so you know it crosses here at -2 and 0. To find areas between a curve and the x-axis, you just add up all of these by, it's called integration, it's just the same thing. And you just use the points where you want to start and end, the x coordinates are those points. Integration. So I'm saying indefinite, not indefinite. Because it has to be in index form before you start. And then you want to integrate -2 and 0 this x cubed minus 4x with respect to x. So by doing that you get the area between -2 and 0 on the x-axis and between the graph and the x-axis. I think it's later, but if it's underneath the x-axis, it'll come out as being negative. And then put in 0 as well, that's going to come out as first because so it's supposed to be 0. Even minus 4 close brackets. But 4, so I'm happy. Between 2 points where it crosses, and all it does is it draws a straight line down from 1, a straight line down from 3, and then works out the area between the curve and the x. You're just going to integrate between 1 and 3, that 3x plus 6x to the minus 2 minus 5. Okay, so I've written it in index form, and then I would just integrate it, substitute in 3, substitute in 1, go 3 minus the 3 substitution, take away the 1 substitution, and then check it on my calculator. This question, it's a slightly more difficult because it hasn't given you a graph. I've given you a little gap here to draw a graph. So it's just a quadratic, so it's going to cross out 3 and minus 1. And then 3 times 1 is 3. So, and because this is a minus x, that means that it is a minus upside down quadratic. So find the area of the finite region between the curve and the x-axis. So that is this. You're just going to integrate between minus 1 and 3, that expanded. With this one, same thing. It's going to cross x equals 0, and it's going to bounce off x equals 4. It's cubic because there's x and then x squared. So yeah, cubic. Find the finite region between the thing and the thing. Sorry, between the curve and the x-axis. So you want to go between 0 and 4, that expanded. Always do it like algebraically and then check it with your calculator. This question, similar, but this time you don't have k. So the way to do that is it's very similar. Find the shaded area under the graph. So again, it's not been printed particularly well, but it's that bit between 0 and k of this function bounded by the curve and the x-axis and x equals k. It tells you that it's 8. Okay, so work out the value of k. All I've got to do is write between 0 and k 3x squared minus 2x plus 2 integrated with respect to x. So that's x cubed squared plus 2x between k and 0. Substitute in k for x. Substitute in 0, that's 0, and it tells you that that is equal to 8. Now I've got to solve this cubic. Hasn't given us any clues apart from I know k is positive, so let's subtract the way to solve a cubic. If you don't have no one's told you what one of the factors is just to try substituting in different things until you get they come out as 0. It's the factor theorem we're going to use, but let's just try 2, shall we? 2 cubed minus 2 squared plus 2 times 2 minus 8 is 0, so it was 2. If it doesn't come out to be the first one you try try other numbers which are a factor of this -8. So I would try, I know it's positive because where it is on the graph, I would try 1, I would try 4, okay? Wait a second. No, that sounds wrong. So when k equals 2, k cubed minus k squared plus 2k minus 8 is 0. Maybe there's not enough space here. So k minus 2 is a factor. I'm just trying to find a value with k. Is it just 2? Yeah. I wonder if there are any others. I'll just factorise. So k squared. So that's -2. It's -2k squared plus k squared is -1k squared. And then what have I got? 2k, so that should be minus 2 times that and 4 times that, which would be +2. Good. And then that doesn't factorise. No. So that's got imaginary roots. I suppose also, if it doesn't say anything about it not relying on calculator technology, or even if it does, you can use this to work out what the answer is and then pretend that you did it. You come out with 2 and then the 2 unknowns. Does that mean I did that one wrong? K times k is k squared, -2 times k squared, -2k squared, plus the k squared is -1k squared. It's very confusing. Let's put it in my... Yeah, okay. Is that what came out the last time? -1/2. Sorry, -1/2 plus 1.93. That wasn't what came out the last time. Yeah, okay, cool. So k equals 2 is the only solution to that. These are similar. Sketch the graph, find the finite region. So that's like I was doing. Sorry. Like I was doing on these previous ones. Sketch the graph, find the finite region by finding where it crosses the axes. It's pretty obvious where it crosses the axes normally because they're given to you in factorized form, but when you integrate it in the expanded form. Okay. This is going to be a combination of the previous things, I think. The graph shows a sketch of the part of the curve with this equation. Use a factor theorem to show x equals, so x plus 3 is a factor, so x is -3. It's going to be one of the solutions, the roots, I should say. And then you'll get this either by inspection or by polynomial division. Factorize that in part C, and then determine the x-coordinates of where it intersects. All of that. So this is chapter 7, chapter 7 again maybe, x-coordinates chapter 4, hence determine the total shaded area. This is the only part of it which is integration. So once you've got all of these, you'll get -3 and whatever those two are. I'll just put them in my calculator to work them out. So it's -1, 4, 11, -30. So you should get the answers -3, 5 and 2. So this one's 2, this one's 5. To work out the total shaded area, just integrate between -3 and 2. Find that area. It's beneath the axis, so it will come out as being negative, but write it as being positive, because the areas in total you want that to be a positive number, but just write it as being exactly, just sort of just, instead of if it comes out as being minus 32 over 3, put it as being 32 over 3. And then do the same integration between 5 and 2, add them together. Okay, but A to D are all previous topics. Advanced is the main thing is to work integration find this area between now is find the x coordinates of A and B. So this is 2, this is minus 2. Then integrate the curve between and 24. So if I find A and whole area, you don't want that whole area, you just want the bit above the line, so you want this bit. So take away this rectangle. It's no more complicated than that.